This problem is all about simulating the process of addition, not with plain integers, but through linked lists. Each linked list represents a number where the digits are stored in reverse order, meaning the ones place is at the head of the list. Your goal is to traverse both lists simultaneously, add their corresponding digits, manage the carry, and construct a new linked list that represents the sum, also in reverse order. To handle this efficiently, the first step is to create a dummy node, a placeholder that simplifies list construction. We maintain a pointer called current, which will always point to the last node in our result list, and a variable called carry to track any overflow from a previous addition. The algorithm operates using a single loop, which continues running as long as there are nodes left in either of the two lists, or there's a remaining carry value that still needs to be processed. Inside the loop, we extract the value of each node. If a list has already been exhausted, we simply consider its value as 0. We then compute the total sum of the two digits and the carry from the previous step. Once the sum is obtained, we determine two things: the digit that will be stored in the new node, and the carry that will be forwarded to the next iteration. The new digit is simply the remainder when the sum is divided by 10, and the carry is the integer division of the sum by 10. This effectively replicates how addition works in base 10 arithmetic, only here, it's being simulated at the linked list level. After creating the new node, we attach it to the result list using the current pointer, and then move the pointer forward to continue the process for the next digits. Simultaneously, we advance both input list pointers, ensuring that at each step, we are adding corresponding digits from both lists. If one list is shorter than the other, the logic automatically accounts for that by treating the missing digits as zeros, so there's no need for additional condition checks. Once the loop completes, our result list, which was being built through the dummy node, now holds the correct sequence of digits, stored in reverse order. We return dummy, next as the head of the new linked list, effectively skipping the placeholder node we started with. This approach is clean, modular, and efficient. It avoids recursion, prevents unnecessary memory usage, and runs in linear time, since we only make one pass through both lists. The space complexity is proportional to the length of the longer input list, because the resulting linked list may contain up to one extra node if there's a carry at the end. What makes this solution elegant is that it mirrors how addition happens at a human level. We start from the least significant digit, add both numbers, carry the overflow, and continue until completion, except now, we're doing it programmatically, one node at a time. By combining a dummy node for smooth list construction, a consistent carry-forward mechanism for digit overflow, and a single traversal loop for performance, this method strikes the right balance between clarity and efficiency. It's the kind of solution a senior developer writes: concise, predictable, and easily maintainable. No complex edge case handling, no redundant operations, just clean, reliable logic that performs exactly as expected. And that's the entire thought process behind solving add two numbers using linked lists, a pure demonstration of how low-level list traversal and arithmetic logic come together to form solution.